Now, a second approach for solving quadratic equations is to use square roots. This is useful when we don't have an x term in the problem like we had in both of the previous examples, or just if we have the x squared or a squared term isolated, it can be easier to just go ahead and take the square root of both sides of the equation rather than doing a whole bunch of extra work to try to put it into a factorable format. And even then, it might not be factorable. So here, in this first example, I'm going to isolate the x squared. So I'm going to divide both sides by 3. So I get x squared equals 243 divided by 3 is 81. And so now that I have the x squared isolated, I can go ahead and take the square root of both sides. And so as we discussed in class, if I take the square root of both sides of an equation, if I take an even root of both sides of an equation, I have to include a plus or minus in front of one of the two sides. And so here indeed we're going to get plus or minus 9, which confirms what we just mentioned, the idea that with an exponent of 2 in the equation I should get two answers. So my two answers are positive 9 and negative 9. And as an aside, when we were here before we had it in, before we took the square root of both sides, we could have brought the 81 over and factored. And so when we factor, we get x minus 9 and x plus 9, since this is one of those difference of squares ideas. And so then we can see that we're on the road to getting two answers. So as I've said previously, whatever technique we use should lead us to the same answer. So that's why with the square roots we have to include the plus or minus when we take the square root of both sides. Otherwise we would lose one of our answers that we would otherwise get by solving by factoring. In the second example here, so we've got x minus 2 squared equals 9. So this time we have an entire set of parentheses that's being squared, but that does not preclude us from square rooting both sides to get rid of that square. So we can still use square roots in this case as well. So on the left, I'm just going to get x minus 2, the square root and the square cancel each other out. And then on the right-hand side, I've got the square root of 9, which is 3, but of course we need that plus or minus, so I'm going to put a plus or minus in front of it. But now, unlike the last one, taking the square root of both sides isn't my last step. I need to still isolate the x, and so I'm going to add 2 to both sides. Now, I have x equals, and I'm going to write it as 2. Uh-oh, we've lagged a little bit here. Let's try that again. 2 plus or minus 3. Now, I don't want to leave my answer like this since I can still simplify. And so what this is saying is we've got two results, 2 plus 3, which is 5, and then we could also do 2 minus 3, which is negative 1. So if we can perform the operation in this case, we should. As we'll see in a subsequent example, there are times where we can't combine the terms, and so then we just have to leave it in this plus or minus format. But if we can perform the operation like we see here, then we want to go ahead and do so and get our answers in as simplified a form as possible. So here's another example where we've got an entire set of parentheses that's being squared. So we're going to go ahead and take the square root of both sides. So on the left-hand side we've got just x plus 4. Now on the other side, unlike the previous examples, we don't have something that we can take the square root of. We don't want to bother to push buttons on our calculator because then we're going to have to round off our answer to some decimal that will make it imprecise. So I'm going to leave it as the square root of 17, but again I am going to include a plus or minus in front of my answer because I need to retain that when I take the square root of both sides. And so now I'm just going to subtract 4 from both sides, and I get x equals negative 4 plus or minus square root of 17. Now, unlike the previous example where we were actually able to perform the calculation of, 2 plus 3 and 2 minus 3, this time there's nothing more that we can do. 4 and root 17, I can't combine those in any way, so I'm going to just keep my answer as negative 4 plus or minus root 17. Now that's two answers, like we should have. If I write it in an expanded format, it would be negative 4 plus root 17, and then of course negative 4 minus root 17. So it's still two answers like we should have. It's just written in this combined format where we can't simplify it any farther than that. For the last of our examples, using square roots, now we have squares on both sides. So I'm still going to take the square root of both sides. I'm still going to go ahead and just copy more or less what I see on one side. And then on the other, I still need a plus or minus. I need a plus or minus in front of one of the two sides. And so I'm going to go ahead and put it in front of the side that I have over here. So now, unlike the others, I'm really going to kind of split this up into two separate problems that I'm going to solve. I think at this point it might be a little bit easier for us to do that. So I'm going to have it be x plus 5 equals the positive version of what's in the parentheses, and then I'm also going to say that x plus 5 equals the negative version of what's in the parentheses. And so now I need to solve each of these mini equations to find the solutions to the problem. So over here I need to gather the x's on one side, and now hopefully we see that we have an abnormality. My x's have all disappeared, and I'm left with 5 equals 4. Or if I subtracted 5 from both sides, I'd end up with 0 equals negative 1. That's clearly incorrect. That is not true. So from this version, I'm not going to generate any answers that I can make use of. Now let's see what happens in the other. So first thing I'm going to do is I have to distribute the negative sign to everything. So I'm going to get negative x minus 4. Now I'm going to do the same thing I tried to do in the other half of the problem, where I'm going to gather my x's on one side, but this time my x's don't cancel out. I instead am going to end up with 2x. Well, at the same time here, I'm going to go ahead and subtract 5 from both sides. So I'm going to get 2x equals, so negative 4 minus 5, so negative 4 plus negative 5 gives me negative 9. And so now I finish out by dividing both sides by 2, and so then I get x equals negative 9 halves, or if we want to think of it as negative 4 and whoops, try that again, negative 4 and a half. Either way is fine. Now, we do need to be cautious on these types of questions to make sure that our answer does indeed make sense. And so if we go back and we plug in, if we go back to the original problem and plug that negative 4 and a half into our original equation, it does still work. Negative 4 and a half plus 5 is going to give us 1/2 squared is going to be 1/4. Over here it's going to give us negative 4 and a half plus 4 is negative 1/2, but that's fine because when it gets squared it's going to equal 1/4 as well. So we've got an answer here. Again, either format is fine. Never a bad idea to go back and check our work on some of these problems where we have to take the square root of both sides if it's a little bit strange like this one was.